Hey guys, how's it going? So in this video, I'll be talking about how to differentiate firstly sines and cosines and how to eventually differentiate any single trigonometry function using strictly sines and cosine. Since if you have tan, we replace it, convert to sine over cos. If you have cosec, sec, and cot, you can just once again convert all this using sine and cos. Okay, so what does the definition state that I wrote? If, for example, the function respect to x equals sine ax, where a is a constant, then the first derivative by applying the chain rule means, so we let u equal ax, differentiate that will give us a, and we multiply the derivative of sine, which is cos. So that's what it is. So the way to quickly understand this, sine ax, differentiate sine, you get cos, differentiate inside, you take it out, would be a. Likewise for cosx. Using the chain rule, so differentiating cos will give you sine, negative sine, differentiating inside will give you a, so you'll be left with minus a times sine ax. So this is quite straightforward. So have a quick recap on the chain rule. And you can click on the annotation you see on the screen right now. This will take you to the chain rule and how to use it. Well, once you're fully okay with chain rule, let's go straight into differentiating anything using sine and cos. Okay, let me rub this board out clean. So guys, trust me, trigonometry is okay if you know what you're doing. So let's start off straight off the bat with an easy example, okay? So suppose we let fx equal sine 2x. Now to differentiate this using the chain rule, again this would just be u. So differentiating this would give you, by the chain rule, u prime times the derivative of sine. So differentiating this would give you 2. Differentiating sine will give you cos 2x. So remember, you just always keep the same thing inside the function. Again, if you were to differentiate this one more time, just for the fun of it, differentiating 2x inside will give you 4x. So you're gonna have 4 here. 2 times 2 is 4. Now differentiating cos will give you minus sine 2x. And opening this out, you can get negative 4 sine 2x. Okay, so this is the idea of differentiating sine, and cos works the same thing as you just saw. Now let's choose an actual complicated example, one that involves a different trig function. So let's recall some trig patterns. Okay, first things first, we know that tan x, where's tan x? There's a proof to it using the Pythagoras theorem. Okay, and I've got a Pythagoras theorem video on this my channel as well. So tan x we know is sine x over cos x. Okay, so we're going to use this relationship and try and figure out how to differentiate tan x. Okay, consider this as a proof as well. Okay, so let's try this out. So suppose we let, let me get my green pen out. Suppose we let fx equal tan 2x plus 1. Okay, tan 2x plus 1. Now how do we differentiate this? Well, first things first, we convert this to sine and cos. So now we convert this to sine 2x plus 1 over cos 2x plus 1. Okay, now notice that if we're going to differentiate this is a method which we've seen before, and it's called the quotient rule. So do you remember the quotient rule? Again, I also have a video on this too, so if you haven't seen the quotient rule yet, this is fundamental to know, to apply this. Anyway, we're going to apply it so we'll know. So the quotient rule. Okay, the way this works, that is that we let the top line equal u and the bottom half of the fraction equal v. Okay, and in this case we have to differentiate both, and then using the quotient rule combine it to find the derivative of f prime x. So f prime x, the derivative of fx f prime x, which tells us is going to be v times u prime minus u times v prime over v squared. This is the definition, if you recall. Now using what we know here, u equals sine 2x plus 1 and v equals cos 2x plus 1. Okay, I shouldn't write in that corner, let me write it somewhere else. Okay, sorry guys. I'm gonna say let u equal this sine 2x plus 1, v equals cos 2x plus 1. Now, taking the derivative of a sine which we know, we differentiate the inside, 2x plus 1 will give you 2, so it'll be 2, and differentiating sine will give you cos 2x plus 1. And now we differentiate v, so once again same thing. Differentiate inside we get 2, differentiating cos we get negative sine, so it'll be negative 2 sine 2x plus 1. Again. And using the quotient rule, it's going to be v times u prime minus u times v prime over v squared. That's how I like to write. And thus, tan, the derivative of tan is found. So this would be dy over dx, or f prime x would equal v times this would be 2 cos squared 2x plus 1 minus sine times 2 sine squared, so this would be plus 2 sine squared 2x plus 1 over v squared over cos squared 2x plus 1. The interesting thing about this one, so we can factorize 2 out. Factorize 2 out, what would we get? 2 can come out here. So we can just say, let me write in green, 2 cos squared plus sine squared. The interesting thing about this one is that we should know that the properties of cos squared plus sine squared equals 1. Okay, so this is something that's worth knowing. So we should know that cos squared x plus sine squared x always equals 1. Notice how we have the same thing. You know, it doesn't matter if it's 2x plus 1 or any other variable. If this property is here, then all of this actually equals 1. So this would just be 1. So just be 2 times 1 over this, which is, let me rub this out clean, which is simply 2 over cos squared 2x plus 1. And another thing we should know from C3 is that 1 over cos is sec. So this is 2 sec squared 2x plus 1, where sec is 1 over cos. And guys, this is the derivative of tan, so the proof of the tan equals this. And we should know, because according to the formula book, d over dx of tan x is actually sec squared x. So yes, this is true and satisfied, and it's all good. So guys, hope this video helped, and if you need any other suggestions, any other problems, please leave a comment below and or PM me. But thank you so much and have a great day.